Okay, thanks. Are you gonna? Why don't you start the?
Yeah. Okay. Good morning, everybody. I just learned that we should have started at 10 o'clock. So maybe you can sit down. All right, so this is the session about next generation ClimateDB, and we'll get a little bit of an introduction from Don about the history of ClimateDB, where we're coming from and where we're hoping to go. And then we'll hear from Martin about the CUAHSI system, a little bit of an introduction. And then I'll try to walk you through the process that I have done to convert North Temperate Lakes LTR climate station data into the CUAHSI format and uploaded it, and maybe I'll even try a live demo on how to look at the data once they are up on CUAHSI. And then hopefully we'll have a little bit of discussion time to hear your opinions on whether this is a good route to take, whether this is something you feel comfortable taking on for those of you who are from LTR. But of course, anybody is welcome to do similar things. The more climate data we have in one place, the better. So I'll turn it over to Don to give you a little bit of an introduction to ClimateDB.
Yeah, so we've had ClimateDB running since about 2001 or 2, and it's to the point where it really needs some rejuvenation with some newer technologies. So we had a meeting back in March in Albuquerque that pulled in information managers from LTER, the Environmental Data Initiative staff, and some scientists, both from LTER and the Forest Service. And some of the things we wanted to look at was what are the current needs of scientists, and what is their need for having harmonized cross-site data set available, and considering what we might do with the existing Clim HydroDB, and considering the infrastructure that we would need, or new technologies or workflows to actually build one of these cross-site multi-site climate and streamflow hydrology databases. So basically, the ClimateDB HydroDB harvesting model is becoming difficult to maintain, and we really need to replace it. And so we explored the CUAHSI hydrologic information system as a destination for climate hydrology data. And the idea would be we would take the existing ClimateDB resource and establish it in the observation data model of CUAHSI, and we tested some tools. The scientists used some of the CUAHSI tools for looking at that information, and we got enough positive feedback to realize this would be a good option to consider for for ClimateDB HydroDB. And so we will be sending a request for comment to the ClimateDB community just to see what, how we might proceed with that. And just a quick background on ClimateDB HydroDB. Each of the participating sites maintain their own data, and they prepare sites in a standard exchange format. These formats are placed online as a URL, either statically or dynamically served. That a harvester comes and pulls that data into a central repository. The exchange format is a comma delimited file, which is consistent, it's very flexible. You can have any combination of attributes for multiple sites, pulled in at any one time. And the attributes and the units are following a controlled vocabulary that we might consider using going forward as well. And the units, they're standardized. So if this is just the old diagram that we had for ClimateDB HydroDB. So each of the LTER or Forest Service data sites are placed online, and the harvester can be triggered or can be auto-scheduled to pull that information into a central database, or we actually had methods to scrape USGS or National Weather System data into the harvester and into the database as well. And then we had a web page that allowed the display, the graph, and the download of these data sets, which was pretty solidly used by researchers. I don't know what, but for a while we were getting at least 30 hits a day on this web page. So we had access tools and some web services as well to access that information. So if we look at what the contribution that currently exists in the ClimeDB, HydroDB, there's 45 sites. You can see it's breakdown of mostly LTER and Forest Service sites. Many of the Forest Service sites, and the LTER sites use USGS gauging station data that gets placed, kind of refactored and re-put into ClimeDB. So there's nearly 400 total measurement stations. Primarily we have streamflow, air temperature, and precipitation, but we did allow the ability to put in about 21 different measurement parameters, but largely it is just those three that was consistently provided by all the sites, and we had over 10 million data values in that database. And so what we thought about doing was to take an archive and otherwise preserve the existing resource, but probably close it off because of the older technology that it's using. And put that archived into the Environmental Data Initiative repository, and hopefully we can do this without going back to each site too much. So we would prepare the data using GC Toolbox or our tools, and we might hear a little bit about this later if there's questions. And so we will provide some generic EML so we can package this up with one data package per site, where each station might be a table of information that would have a multiple wide table that might have air temperature, precip, and all the other variables that were included for that site, all into one table. But then there could be multiple stations. And so that's how we would organize it within EDI. And the sites would have the ability to update that before we do this, and so the ClimeDB interface can still be used. And we will consider what a deadline might be for the closing off and ending of ClimeDB, HydroDB. The other thing we would do was explore putting this whole resource into the CUAHSI HIS. And so we would begin to prepare that data in that framework. And I think we're going to show some examples. Corinna was going to show some examples of how she did that for her site. And CUAHSI requires that you populate these 5 metadata tables. So that would need to be done for each of the participating sites in ClimeDB. We might do that as much as we can by harvesting metadata from the current ClimeDB, and or we would just otherwise by manually populate the CUAHSI templates. And then we've already mapped all the ClimeDB parameters into CUAHSI parameters, so that's been done. So this would serve as harmonizing the information across all the sites. And then we would actually upload this, these 6 tables, 1 package per site, into the CUAHSI observation data model. And then finally, in the future, we would hope to take the resources that are already in, that sites have put into EDI and prepare them so that they could go into CUAHSI. But we might first take like high temporal data and harmonize parameters and units in such a way that that it could be put into EDI. And then we might just select certain stations and parameters to harmonize it first. We might even keep native temporal resolution of the data to put it into EDI. And then the next step would be to actually maybe aggregate the data to an hourly format, once again harmonizing and selecting priority sites for putting into CUAHSI. So that would be a quick view of what the next steps would be. So I would take questions. That's all I had. Yes.
Hello? Yeah. I can skip that.
Can you use this mic?
Hello.
Oh.
So sorry, this question is not directly about ClimeDB and HydroDB, but it reminded me of something I work with, StreamChemDB, and I'm just curious if your conversations have included or touched on StreamChemDB.
They haven't lately, no. StreamChemDB was a database that was put together that ended up including primarily nitrate and ammonium type data, and it's still available at Oregon State. And so that's something we can still consider. Does EDI doesn't have that database at this point. We would have to put that there. Okay, so that could go into CUAHSI too. So it would be worth considering. Okay, sure.
Also a little bit of a sideways question, sorry.
Oh, yeah, that's okay.
I was wondering if these stations engages or networked, or is this varied by LTR?
Each of the stations, there are 4 service and LTER stations in there. They're not, I mean, by network, do you mean they're?
Are they online? Are these manually downloaded files? I guess that's what I was trying to understand.
Each of the sites maintains their own data sets and manually prepares this particular exchange format for this database. They're not, they might be online at each of those individual sites, but the preparation into ClimeDB is by each individual site. Does that answer your question?
Yes, thank you.
Yeah.
I was going to add, we might be able to link to it. And if we can find out if there is an online presence, we should be able to link to them in the future so that you could see in an archived snapshot, plus have a link to an online presence of the sensor. Probably, I know where that goes.
And so now I think we're going to hear from Martin talk about CUAHSI.
So if I get this working here, you know how to do it?
We can just escape.
Yeah.
And then
You probably,
you're over here. Just double click on that, I guess.
now it's converting, okay?
And then use these keys to
And do you
advance.
know what? Let's go to,
Oh, just hit this, yeah, and use these keys to advance.
okay. So now I will need my glasses. I can maybe talk this way. Okay. Yeah, my name is Martin Seul. I'm working for CUAHSI. I'm the technical director there. And I will talk a little bit about CUAHSI itself a little bit, and then go deeper into HIS as the tool that is proposed for really working with the LTERs. So, so CUAHSI, if you're not familiar with us, we are a nonprofit organization. We are a consortium of roughly 130 academic institutions. And our mission is mostly to really work with universities to help them with strengthening the collaboration between the different organizations. I think I can't do it without my classes, but unfortunately, and to develop and deliver data models for the community. Another area we work in is the promoting education. So the key activities that we are involved in are community services. As I said before, we do webinars, provide funding for students, for travel support. And the other area are the data and models. That's the area where I'm working in, where we're trying to provide tools and mechanisms for archiving and distribution of data. And we have two larger systems we operate. One is HydroShare, which is more file-based, and the other area is the time series-based HIS system. So, and that is what I'm going to talk today about. It started as a research project more than 10 years ago, and we have Emilio here who's been involved in it for about longer than that. And we are operating it, and we are hosting most of the data in our system. So everything is cloud operated. It started very similar to ClimateDB as a local database, but through the years we moved it into the cloud and made it more ready for the 21st century. So one thing to note is that CUAHSI, we don't own the data. We are just helping people publish the data. So the responsibility and the ownership of the data still resides with the people who created it. We are just trying to be the middleman between the researcher who created the data and other researchers who need the data and want to look at it. So that's our role in the whole enterprise. And we are constantly adapting and working with the system to improve it. So as we now see, the amount of data that comes in is ever increasing. So our task is now to really think about how we can scale up the database, scale up the performance, look into different tools to do that. So we are really involved in making the system better. So it's not a stale system. It has evolved over the years, but has proven to be helpful and useful for the community. The general structure is fairly straightforward. So you have an area where the data goes, that is the Hydro server, so people upload the data. We have a central catalog that really looks at the data and grabs the metadata that we also host. And then we have tools to actually retrieve the data so people can find it and get it down to the system. And so these are the key systems that make up the HIS system. So I'll go now a little bit into detail to just describe each of the areas, but still I'm trying to stay fairly. I don't want to go into too much details. So the area where you would register data and where organize a catalog is a HIS Central, we call it. It's a web application where people just get a landing page for their web service. So this is where you describe some of the metadata of the entire service and make it public and manage that. The Hydro client is a tool that we developed. It's web-based. You can log in. You don't need to log in. You can. You go in there and you find all the data that people have published with CUAHSI. And also additional data that is published from USGS, NOAA, or NASA. So we're trying to have a system where people can go to one place and find data sets across multiple organizations. So it's not just one single service we show, but we try to give a better picture of all the data that's available in a certain area through many different providers. And as I said, it could be the Citizen Science Group, it could be USGS or NASA. So there's quite a different scale in the data we have. And all the data is publicly and free available for download. So what we are concerned now for this project is mostly Hydro server, which is the area or the tool where we upload the data. And Corinna will be a bit more adventurous than I am and actually try it. I'll just go through some slides, and that's the safe side right now. So the way we set this up is to essentially just request a publishing account. But this one does, it creates a database in the back end. And the only thing you need to do is work in the website. There's no need for you to do any IT work. Everything is set up for you. So it's very convenient, and we have learned that it's really beneficial to have one central organization who maintains the IT, and to not have individual researchers trying to maintain the IT. Then, because we all know once a graduate student left to set it up, things become very difficult. So after that, you would need to format your data. As was mentioned earlier, you have to conform to a certain standard. And that means we are requiring a minimum amount of metadata to describe the data. You're not free to do it as you wish. So some people, I think it helps with really organizing the data in a very standard and organized way, so you can actually aggregate data across different LTRs or different CZOs or different groups. So you're not really have to go through and massage every bit of the data that other people have. So, and the structure we came up with, and it was well before my time, Amelia was involved in this, when we did the observation data model, which came out of the community as a model to describe hydrologic data. This is a data structure. I don't want to go into too much detail, but important is that there are different tables that describe different things. For example, when, where, how, what, and when. So these are the 5 different things you want to know about an observation, and they are represented in the data model as well. So for the techies within us, they can look at it in more detail and ask me questions about it later. For now, I just move on and describe another section that is important within the data set with ODM, is that we have controlled vocabularies. That was also mentioned. So you see some similarities with the HydroDB system and ODM, because they're trying to solve a similar problem. So that's why they align very well. So for me, it looks like a fairly obvious choice that there's a relatively simple path from ClimateDB to ODM1. So hopefully that's the case going forward. But this dynamic, this controlled vocabularies really limit a user to really pick from a small set of vocabularies. So you don't have to go back and massage data. So it's always trying to standardize the input. So it will make the discovery later once we search for the data. When you after you requested the database, everything is set up for you, then you have to upload the data. And to make it easier for you to really conform to the structure, we built this formatting template. And that is you can download it from the website, and it really goes table by table and describes how you need to format the data to conform to the system. Once you've done that, you can then upload the data into the system. At that point, it will still check if you have conformed to the structure, and will complain if you did not. So that you really that the data that goes into the system is as organized and as structured and as accurate as we can. Yeah. So these are the things that, again, repeat a little bit. Again, it gets checked. You have multiple people who can access the database, so you have a team working on one particular database. You can keep the system private until you're ready to publish it. We also have something called a standard and an advanced mode. Often it's sufficient to just have a small the minimum of tables that you upload is of the size, the variables, methods, and so on. That is typically sufficient. But if you have a more sophisticated metadata profile, you can go to a more advanced standard to accommodate the extended metadata that you have. So once you have uploaded the data and everything is in there, you can come to us. You can request the publication. We are setting up a web service, and we can register it with a Hydro client, so the data can be available to the public. And the important part is that we are a long-term archive. We are not a project that it will go away. So the idea is that we are really NSF funded. We have a long-term repository accepted by NSF, and hope to provide that service to the community for a while. We just got another 5 years of funding, so that's good. Once you're done with that, you can get a DOI for your data, and hope that people, or at that point, the data is available for other people to download, to look at it, and give you feedback. And that's really what you're trying to do, really to connect the researcher who has the data to the researcher who needs new data. And that was all I had. So I'm happy to get more questions. Yeah.
So, can you hear me? Yeah. So is the data discoverable through Data One? How does that work?
Well, that is something we have started to do now. We have also worked with HydroShare, and HydroShare is we work with we enabled the schema.org schema for HydroShare, which enables us to really tie into into Data One. I talked to Matt Jones yesterday about how we can do a pilot with getting that into the system. So it's a little bit easier for HydroShare because it's file-based. We have not really done this for the HIS system, but it would be something that we evaluating once we have the HydroShare into Data One. This is a bit more complex because of the dynamic nature of the retrieval. So it's something we are looking into, but we have not done it yet for the HIS system.
So the HIS system doesn't provide any DOIs, it doesn't provide any versioning, and it doesn't provide the conditions to actually feed into Data One. But the data would still be available through Data One from the EDI repository. So the HydroShare that Martin is describing works very similar to the EDI repository. And that can be discovered through Data One.
Like the process would be that we would put
Just for the online.
yeah, so the process would be that we would submit our data through the CUAHSI process, and then EDI would discover it and download it from CUAHSI.
It would go the other way around. You would submit the reformatted data to EDI as the next version of, or a derived format of your original data. And then both of those versions would sit in EDI, would get their DOI, and every time you update it, you would do the same thing. And whether we can automate then the process of getting them into CUAHSI or not, I'm not 100% sure. But every update is really straightforward and very simple because you need the metadata in there only once. And from then on, every new data can go in fairly easily. We have to work through the details on whether each site wants their own login. So CUAHSI has these services, which would be each site. It would make each site much more discoverable. So I don't think we want LTR data in there. I think we want every LTR site to have their own service in CUAHSI. Does that make sense? Okay.
I think you just answered my question, so I'll repeat it back and you tell me if I got it right. I take my small time step, say mineralogical data, I put it in EDI, and I run something to transform that format to the appropriate quasi ingest format. I put that in EDI, and then I run the wonderful web service Corinna's going to write for me that's going to harvest that into CUAHSI. Now?
I'm not committing to writing a harvester. There may be another manual, right there, at least in the beginning, definitely. So.
But that's it. The 5-minute goes into EDI. I run my aggregation script. The daily goes into EDI, and then I run something.
You click a few buttons. Yeah. You don't want you click.
was just a comment on the standard format versus the advanced format, because because ClimbDB has qualifying flags that we put after every single variable that we have in there. The qualifier attribute is only in the advanced template. So we will be, if you go to CUAHSI to look at the templates that they provide, it looks like we will have to be going to that one to really provide the full metadata that's.
But you can mix and match. So you can start with the standard and then just add the qualifier later. Yeah. So we start with the standard first and then go to the qualifier, add that later. So you don't need to, you can mix and match if you do. They go to the same database, it's just slightly different. One slightly different, a simpler format for the standard one.
Or would it override what you had put in there?
No.
So if we want the qualifier in there, then we have to go to the advanced from the beginning.
No, I don't think so. But I don't think so, but I'll double check.
Oh, well, just to know. And also with stream chemistry too, although there's the speciation is also only in the advanced.
Yep.
So for stream chemistry data, you would need the advanced template as well.
Yep.
Martin, you put, you had listed up there that the HIS can coin a DOI.
Mm-hmm.
I didn't think that, I thought DOIs required a static data set. That's a continuously,
Yes, but
continuous ingestion system.
yeah, the way there have been different thoughts about how to provide DOIs for a data set. We provided DOI for the landing page of the HR Central page. So this describes the data, essentially that's where you go on, that is the landing page that is static for the system, not the individual data. So,
Okay, so it's a DOI for the metadata. Essentially.
yes, essentially yes. So it describes the service. So the service gets a DOI, not the individual data. So that's one way to at least link it back to so people can download the data, they get this DOI with it, they know where it came from. So it's a little bit of a there's a trade-off between providing DOI, giving some for the data, and being totally precise and really having a non-static data set for DOI. So and there are different school of thoughts about it. Some people say it's okay to do that. Other people say no, we can't do that. We went along with a hybrid to give at least something, because really we wanted the ability to provide a DOI for the data set so people can at least trace it back to who the originator is. It's not optimal, but it's at least it's better than nothing.
Okay, thank you.
Any more questions?
Yeah.
Please ask some more questions.
But what you can do, you can move the data from HIS into HydroShare, make a snapshot, and then give a DOI to that particular snapshot. So that works. So then you have a DOI for a static data set. So there is some connectivity between data that lives in HIS and HydroShare, which is more, as I said before, more file-based, while this is more SQL Server and service-based. Yeah.
All questions answered?
Yeah, so see, this page would get a DOI.
So that's our NTL LTR data or our service. Okay, so Adam, do you want to give a really brief update on how far you are with ClimbDB conversion, or? No, okay, all right, okay, that's fine, whatever.
We should talk sometime.
Sure, we can give it, yeah, it can be brief with the slides.
Come on here.
Okay, so So you saw from Don's slide that there are on the order of 250 contributors based on sites? No. Anyway, there's a lot of contributors to ClimbDB, roughly 50 organizations with multiple sites each. Adam, and this is one of my tasks actually, but Adam's helping because he's an expert at the GCD Toolbox, and we'll also have Wade. So what we're doing is using the GCD Toolbox can actually already read from ClimbDB, so we're using that to create mappings into the ODM format. So the first conversion of ClimbDB and data to ODM will be done through the Toolbox in large groups. We just haven't actually mapped out exactly what the groups are or how they're identified by site, but it's going to be pretty much the same as the contributor sites in ClimbDB. And that will also include an EML template that gets as much of its metadata as possible from the metadata that's in ClimbDB. And so those two things will be exported to EDI. So that's, if you know your data, that's roughly, or the way you package data, that's the same order, 50 data sets, each with the 6 tables in ODM. And then those could be made available to CUAHSI. We are anticipating that some of the metadata in ClimbDB is incomplete. So there is going to be this communication step where we figure out how to get the rest of it, and whether it's you all maybe updating what you've already got or some other mechanism, we'll figure that out as well. But what we have right now is the mappings to generate ODM tables from ClimbDB input and a partial EML template. So I'll be in touch.
So as part of the ClimbDB, there was a USGS sort of connection area of discharge and whatnot. Is it going to be necessary to do that going forward? By pushing USGS?
Yeah.
Is it possible to have an arrangement with USGS for that kind of thing?
It's one of the fiddly bits we'll figure out, because because we had the same thing happen with us. We have different versions of USGS data. Some of it's in ClimbDB anyway, yes, I don't know yet. But we don't want duplication, and we want to be aware of when that might happen, so we'll be careful.
Yeah.
Oh, and I think USGS is already in.
Yes, we do have the daily values and the instantaneous values for the USGS in the system. So that's constantly available. So and the groundwater as well. So these are the main things you have from USGS.
And that's, yeah, so to avoid duplication, we'll look and see what's already in CUAHSI and make sure we aren't doubling up on anything. And it's one of the advantages of using it is that you may have, USGS sites can come and go, and they may be appearing at places that are close to you and you don't even know. But CUAHSI would know, so that makes it a little easier to get hold of.
We try at least.
All right, I obviously wasn't planning on not doing this on my computer, so forgive me that A, I'm not a Mac person, and B, don't remember my passwords. No, I just need somebody to remember things here. Okay, so what I have done is I have started a Git repository in the LTR group. So if you want, you can go there. Git repository LTR climb hydrodb 2.0. That's what it's called, with dashes in between. And I've put a few things in there. So there are subdirectories for CUAHSI documentation, which has the PDF of the standard uploading guide, which you can take a look at. And then it has the standard formatting template, which you can download in several places. I'm just putting it in there for convenience. So that's there. And then I have put the meeting notes in there. So those are notes from that meeting that we had in Albuquerque, if you're interested to read them. Again, it's just for convenience. They are somewhere else too, but somehow I'm always losing Google Docs. I don't know if that's just my problem or. Okay. All right. So anyways, they're there. And then I have started an NTL folder, and I'm hoping that maybe all the other sites will do the same thing. And inside my NTL folder is now my one data set conversion that I have done so far. So that is NTL 17, which is the idea for the ID for that data set. And inside each one, there probably would be something like an R script or whatever other programming language people want to use or not. If this goes through the GCE toolbox, then obviously you don't have anything to archive. But this is what I've done, and there are now two. One is to convert my format into the CUAHSI long format, and aggregation to 15 minutes is what it's right now, because I didn't read them in the meeting notes and I forgot which time step we wanted, and I think we had agreed to hourly, which is obviously still open for discussion. What time step is it that people really want? What is it that we can provide? What can CUAHSI take, really? That is another thing. So 20 years of 15-minute time intervals is probably a bit too much, but no, it's not. Okay, I'm glad you're shaking your head. No, Colin. The other Colin was shaking his head. So, and then you can also see that I have a make EML file in here, and so that is the workflow that we're proposing here. That you take your original data. So now we need to see if I can show this here. Yes, I can. So this is the file that converts my big long, not big long, big wide climate file as it comes off our, what we call the airport buoy. Just get it, airport buoy. So it's not a buoy at all, but everything else is a buoy in our site. So this is the airport buoy. So all I'm doing is reading in a fairly large CSV file and reading it into a data frame. Then I'm figuring out the datetime format, and then I'm cleaning up a little bit if there is any NA for the datetime. That's all I'm taking out actually, and then I'm aggregating it to 15 minutes, and this can be aggregated to anything. So it can be aggregated to hourly. And then I'm taking it apart into the different methods. So obviously precipitation, temperature, all of these will have different methods. Relative humidity, wind speed, I've got in there. And then I thought I needed all those flags, but then I realized for the basic standard upload format, I don't need to go into the details of flags, but we can. There's some code for it. Then I'm turning it into the long format here, each one, adding up all the temperature data sets, because all temperature, whether it's mean, min, or max, all have the same method. Obviously, they all come off the same sensor. So then I'm adding columns according to the CUAHSI format. So I've got the method code here. And then I'm putting them all together into one big long data set. And then we're just adding a few more columns here, like the UTC offset, which for my site is -6. The site code is AP, which means airport buoy. It doesn't, it's AP. And then the source code, which is NTLLTR. So that is where all of this is coming from. And the quality level is 1 because it's quality controlled. And then I'm calculating the UTC offset by subtracting 6 hours from my time column and add that too. And then here I've got the DF ODM, the data frame ODM format, and these are the headings that I need for that file. And so my data frame now has the exact same format as it is needed for CUAHSI. And then I'm chunking it up because CUAHSI uploads only take about 500,000 records. And I forgot about that when I first tried it, and it did not take that 2 million that I was trying to upload. So 500,000 records per upload. So this is really all I'm doing in this script here. And now I need to figure out how to get back here, back out of it. So what I've done now is I've created 4 files manually, and I'll show them to you, which I have here under the data. Even though it says data, it's not my whole big CSV file in that GitHub. It's just these metadata files that Martin talked about. So we have the methods CSV, the quality control level CSV, site CSV, sources, and variables. And these are extremely simple. So let's see if I can show the source file. So the source file has one, damn it, why can't I make it readable? It's got this. Anyways, it's got just one record because it's all MTL LTR. And all it says is asking for a few contact information. So straight out of your EML, whatever you have in there as a contact, and what you want to call the site. That's the sources. Then within your sources, you have sites, which I think you called stations. So it's a little different terminology. So there's my Woodruff Airport buoy. It has a lead long, and then there are some controlled vocabularies that fill in the rest. So it's obviously on land, it's not on water, and that, again, is pretty much it. Again, this is the where now, the where out of your metadata. And then we have methods. And so for me, this is all sensors. And in the first column, that is a name that I dreamed up. And anybody can dream it up according to what you would call it at your site. And then there's a method description. And that obviously can be longer or shorter or whatever you would like it to be. The only thing you have to remember is what you called this method, the method code. And that is surprisingly hard. So I've, not to make any typos or forget what you called it. And then once we've got all that, then we need to describe the variables. And again, this is probably the slightly more involved table. And this is probably a table that we may want to talk about on what to call it. So the first column, the variable code, again, is up to us, each one of us. So any program can use a different one, or we can agree on using the same. What I have done now is I have used the terminology that comes out of ClimbDB, except I took the daily off in the front. So I still have air temp mean C, air temp max C, air temp min C, wind speed MS, rel humidity percent. I think that I made that one up, or maybe it comes out of, no, I think it comes out of ClimbDB. And precip total millimeters, mm. So they are straight from the control vocabulary that we already had in ClimbDB. And then the next one, the variable name, that is a control vocabulary. And that is where you can choose and where you have a few choices. So there's precipitation, there's temperature, wind speed, relative humidity, and that is what's available. And then the variable units names are controlled vocabularies. So that again has to be picked out of the CUAHSI controlled vocabulary. Data type is a controlled vocabulary. So it's either cumulative, average, maximum, minimum, average. And then the sample medium. And here I already found some curious differences. I'm calling all of this air. And when I start searching everything else around my airport buoy, I find people who are calling the precipitation, the sample medium, soil. And so I wasn't quite sure how they came up with that. It's USGS, I think. So I don't know. There's a value type, which I considered all to be field observation. It's another controlled vocabulary. It's regular, yes it is. Time support is 15 minutes. So again, time support, the number is what I put in, and then the unit name is a controlled vocabulary. And I really don't know how to do this on Mac. How do I move? Okay, got it. Yes. Time units name. It moved. It just moved. Okay. All right. So the time units name again is a controlled vocabulary, and then the general category is a controlled vocabulary. And again, here I've seen people choosing other things than climate, and so that again may be something we may want to agree on. I don't know. I think it may depend on what people have in their minds, what these data are used for. So anyways, so these are the tables that need to be generated or need to be probably fairly manually put together once for each station, for each variable, for each source. And once they are done, that is the metadata. And I'm sure you already have seen the exact mapping from EML into these kinds of metadata. So the metadata content in CUAHSI is very similar to the EML. And then I have all my make EML templates, which go with the EML assembly line. And these now really should be the same for all of us, because the format of these data sets is now the same all across our sites. So in theory, you should be able to simply just copy and paste whatever I have done here to generate an EML. And once we convince Colin to apply all that coding that is already out there for the EcoCom DP, pretty much all we need is for you to put in the data set ID for the original data set where all of this is coming from. And then it should be able to pull a lot of metadata from the original raw data file. At least that's my idea right now.
Want to summarize? Makes sense to me, but I've already worked with both those formats. So.
What summarize? So I'm not sure what you're asking me to do. Yeah. Yes, we'll get there. Okay. Yes, as soon as I find, okay, I didn't mean to do that. So I obviously didn't succeed in finding my data set here. I'm sorry. Anyways, I've put this data set into staging, into our EDI staging environment. Jeez, I didn't know other people are putting data in there too. Probably should have searched for it. I'm sorry. That's what I do when I don't work on my own computer. Anyways, it's in staging. I was hoping to show you.
Well, I was just thinking, do we have a?
Probably.
Do we have a keyword, climb deep, or CUAHSI, or ODM?
That's a lot. That's a lot. Yes. 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 Thank you. Okay, so what I've done here now is I followed the ideas that we had for the EcoCom DP harmonization. So it's now the same title, and if you can't see it, you should just come a little to the front.
Yeah, come through.
I don't even know how to make this bigger here.
Or go to, if you know the LTER or the EDI portal, go to data set
370.
370, NTL 370 in staging.
Oh,
See,
it's sort of the same, actually.
Yeah, command
do
and
that.
plus or
Okay.
minus.
How to get
All right.
package ID.
And then I've appended this CUAHSI ODM format to the title. And everything else is the same. All this information, but here now you see the data tables that I have created. So there's the data values, which is the main table. That's the one that now has 257 megabytes. There's the methods, CSV, quality control level, sites, sources, variables. And here's the R script that did this whole thing. And so eventually this whole thing would go into our production portal. And then I've gone ahead and uploaded it. And here Martin, you need to help me here. I'm failing to get my.
What are you trying to do?
I'm trying to log in and I can't remember my.
Into the data server, into the hydro server?
Yes, and the data upload.
Yeah, hydro server, the CUAHSI.
Hydro server, right?
Yes.
This one.
Yep, that's one. The other one is just the registration.
Yes, and I can't log in. Can you please log in for me?
On the hydro server, try it again.
So once you have an account on the hydro server, this is. No, I don't. I don't remember my password. I have 2 accounts there.
The second one.
No, I don't remember my password.
Okay.
You log in. There's CUAHSI.
Oh, yeah, yeah. Yeah, I can't remember my password.
That's the hard part. I never log into Gmail ever. Okay.
But
All right.
You're now an administrator, be careful.
Okay. All right. I won't do anything. So this is the interface that you get once you've got all your stuff together.
Looks a little bit different because you're admin, but
Yeah. So on this side is the standard upload, which has the formatting template here, the formatting guide, and the uploading guide, which is what I've also put into the GitHub. It's the exact same thing. And then once you click on the standard upload, all you get is an interface where you can drag those files in. and say upload. And you start with those metadata files, the little ones that I showed you. And then once they are uploaded and checked and everything, you can see here on the right side what you've got. So Martin obviously has 214 sites. For me, it would be 1. And for me, it would be 5 variables and 1 source and 5 methods. No, 3 methods, whatever it was. And right now I have about 2 million records in there. So that's what you can see. And then again, in the standard upload, you just keep going back to the standard upload to upload more data records, one after another. If you've chunked it up to the 500,000, you will be uploading for a little while.
One thing to add there is that we're also working on a more of a curl-based like API situation where you just have your files in your machine, you run a script, and then it goes automatically in there to make it a little bit more automated. So that's something we have in the pipeline. It's in beta, so we have people looking at it. But hopefully, if we can get our staffing in place at the end of the year, we have everything in place for this to be completed.
See, that's the reason why I didn't commit to a harvester. It needs to work on the other end too. But once that works, we probably can do it. So that's that part. And then once it's all in there and you're happy, you request a first-time publication. And then maybe you get an email from Martin that says, all done. Or you get an email from Martin that says, well, you have some issues there. There probably aren't any issues because you can't even get the data in if you have any issues. So there is a lot of checking going on before the data go in. Okay, I'll sign you back out, right? Maybe. Probably a good idea. And then when all of this is published, you can find your data here. Oh, we've been there already. How do I get out of this? No. What did I do now? I didn't highlight it, huh? It's now searching everything. Yeah, it's searching everything.
Yeah.
Okay.
So it resets once it times out, it resets.
Yeah.
You can just pick, if you go into the data services, you can just pick the one you want.
See, that's what I tried. That's where it was.
You have to highlight it.
I thought that's what I did. No.
Now you search.
Okay. There we go. Okay, so there are my 5 variables. There's my LTR airport buoy. And there are all the data. So once you've got this here, it comes out as this. So I've got precipitation, relative humidity, temperature, minimum, average. There should be more, right? How do I do this? Anyways, so I now can save my selection to the workspace. Which is now minimum temperature. So it's now generating this for me in my workspace. It is quite a bit of data, really. 15-minute interval is quite a bit of data. So
maybe we can interject here about the workspace, about the idea.
go ahead.
The idea behind the workspace is that you don't need to download the data if you don't need it. So you put into your workspace, it lives on the cloud in our system. If you're logged in, it actually persists to your next session. So if you have a data set you walk in continuously, they keep on in your workspace, so they're persisted. If you don't log in, they get thrown out. But the idea behind this, you can upload the data into your workspace, play with them, visualize them. So you have a place in the cloud where you can walk, and only download the data if you actually need it. I think it's useful to you. So that is the idea behind it.
Does it track, does the tool track provenance so you can reproduce the workflow that you?
No, this is really essentially you just go and get the data from an existing source. So no, it does not really track that. It only, when you download the data, it only tells you, it gives you a list of CSV files with begin date, end date. So there's no real provenance. So it puts in a DOI or a citation in there where the data comes from. If that's what you mean, that's part of the download, yes. But there's no real, but that's all it is. It's really, there's a citation in the download. If you specify it. It's up to the publisher to say, okay, that's where, that would be the citation that comes with it.
So this is not completed.
There's a question, 1 second.
Oh, go ahead. Yes.
So
Sorry.
this process that you described is how we get our existing data into CUAHSI. What I wonder is, so the current, or I guess the historical Climb DB, I think we uploaded new data on a daily basis. Is that the plan for this, or is that just going to totally crash the system because there's going to be too many DOIs generated? I mean, how, I guess my question is, how often are new data going to be uploaded to the system?
You've done that daily?
I think you could choose.
Yeah.
Yeah, I think at the setup, it was set up to do it like
Okay. Well, I don't think EDI can handle daily. Once this works, that might. So once the uploader, the more automated uploader works, that might work. And then you want to do snapshots into EDI every so often.
One thing to add there is that there's you upload the data, that's typical, and then another process has to happen. That means, for example, it checks for duplicates. So if you could upload the same thing twice. So it can happen. The database initially takes it, but then there's a process of, before it gets published, it checks for duplicates and removes them. So there's always, so that's why we don't do this like every day. Most data sets we host are sometimes already completed, or there is not often that we have daily updates. So we typically harvest once a week. If that is different for your site, you need different, then we can adjust to that, but that would be something we have to then change within our system to really harvest more often. We can do that for particular sites if that's desired. So there are options of how to adjust the system for your needs. Once you go down in the details, it probably can revisit that. But the system can take data, that is no problem. So it's just really how the data gets published, because there's a step with getting the data into the system and getting the data to be viewable in here. And so you have to recatalog it because the catalog changes, because it's a longer time frame now. So this is always something we typically do, not daily, but once a week or so.
Can't keep quiet. As a user of this kind of data, can I make a general plea to everyone to upload data as high resolution as Mark will let you?
Yeah.
While hourly might be the most common use, anybody with a data frame can downsample from 15-minute or higher resolutions to hour themselves.
Yeah.
But I can't upsample
Hmm.
from hourly into 15.
Yeah.
And so you're losing critical data.
Yeah, I did do the calculation, and if you have 20 years or 15 minutes, that's around 2.5 million data sets, data points. That the system can handle that, and especially if it's in, so that you cannot download everything in one go, because now we limit the amount of data you download to 500,000. So that's 5 years of data on that resolution. So it's you would have to then do it in smaller chunks, so you can get the data. We are working on a system where you can download more, but that is not ready yet, because we had trouble with retrieval of large data sets. So that's why I've been talking to you about the Dendra system.
Have to continue that. You can also do dynamic resampling.
Yeah. So something, or when you upload the data, you could sample. You can upload the data in different intervals. So you could have a time series for hourly, or for 15-minute, or for, you could already pre-aggregate in the database. The problem is not the data that goes in; it's how much data comes out at one time. So just if you have 10 million or 5 million records in the database, that is not a problem. It's if you retrieve a very long time series, high frequency, then the system becomes a little bit slow.
Like all.
One other minor thought is with the methods, it has an option within ODM1 to put a link in. I've had a lot of success putting in the manufacturer's stat page there. So I tend to use with ODM1, I put the name of the piece of equipment as my method. I just copy and paste whatever the manufacturer describes, and then the link to their webpage where you can get the PDF manual specs for the piece of equipment. I found it incredibly useful for long-term maintenance of equipment. Thanks.
That tends to work for the people who do the data in the sensor set. I'm having a hard time getting that kind of information out of our sensor people. So.
How long do we go? So we're running 30?
Yes, 5 more minutes.
Okay. Can I actually, so I have a few summary bits, and just kind of listening to people's questions and seeing the demo myself, and thinking about a few holes and what we should do next. And I can kind of see that we might need a few webinars, one on the ODM format itself, because it's optimized for the way that CUAHSI accepts data. Is optimized for querying the data itself. So that means that some of the metadata actually ends up in tables so that you can be uploaded into the system. And that's a little different the way if you are used to making EML data packages the way I'm used to it, you have wide tables with lots of metadata in the EML. This is a twist on that. So that would be like, so what does this format look like itself? What are these 6 tables? And what entity-specific metadata is in the tables versus what's in the high-level EML, then how to make it, because in addition to making it with R, the way that Corinna described, you actually can once we have all the templates worked out, which we'll use the ClimbDB data to generate, you could use the Toolbox to generate this ODM data package also. So if there are people who think they might use Toolbox for going straight from instrument data or from your raw data into ODM, you can raise your hands now or come back to me later. So there's that. And then the whole idea of, all the issues surrounding submissions to CUAHSI itself. How does that actually work? So if you think of something else, chime in right now or anytime you feel like it. And I'll put these notes will be in the notes folder in the GitHub too.
And I'm going to put another plug in for our office hours. We're there for all your questions on Wednesdays. 2 to 3 Central. Yeah, we always announce it. It's always on the same time, and it's on our calendar. So if there are very direct personal site related questions, otherwise if we have more general ones, any kind of online webinar, anything.
and also feel free to reach out to CUAHSI if you have any questions about what we do, about the system and so on. So email help@cuahsi.org or call me directly. So either way, we're happy to help. That our job is really to help the community.
So overall impressions. Anybody major? No, thumbs up, thumbs down.
I'd just like to express appreciation that you guys are figuring this out, because you're going to have lots of users, at least 28, right? And I was not at the workshop earlier, so I want to thank those of you who were and those who've been working on this.
Anybody with a thumbs down? Carol?
Not a thumbs down. But I just want to follow up on what Gaston was saying, and it's, I mean, we'll be contributing data, but we also need, our users are the scientists, and encouraging them to go to CUAHSI to use that data. I know that a lot of people at my site are very dependent on ClimateDB, so we're going to have to be doing some training about, you know, how to go to CUAHSI and get the data that they're looking for. We need to kind of push on our scientists.
One more thing for me. It would be really good to understand what kind of data, how they need the data. Because right now we have a standard format at the CSV file, how the data comes back. If there's something different that they need, then we have to look at that. You can also access the data via Jupyter Notebooks. So you don't need to go to the disk client. You can buy there's an API how to get the data out. So, right now we have a standard way how we do this, but it might not conform to what you need. So there might be a different way of presenting the data. So we are open to adapting the system. We did a similar process with the CCOs. They're moving their data into HydroShare because it's more file-based. And we also went through a process of really doing this now, how to adjust the system to really conform to your needs. So there's always some negotiations of what we can do, but I think we are trying to really adjust the system as much as we can to your needs. So there would be some within reason we are trying as much, but it would be good to understand what you actually need the data set, how it should be formatted for your needs.
I walked out and just came back, so my apologies if this has been covered already, but I just wanted to mention that, or remind people that the CUAHSI HIS provides web services for accessing the data. So as a community, we are in ClimateDB. One possibility that you can consider if you have resources is not just that you have all the data in CUAHSI and you have access to HydroClient, which is all great, but you can also build a lightweight client, say hosted at EDI, that has a map that brings in the data from CUAHSI directly from the web services, where again you make it lightweight, you show all the points and the ability to maybe select by LTER site, and you don't try to rebuild the capability that is in HydroClient, but just as a quick one place to identify ClimateDB. I forget the other part of that. ClimateDB is something else. HydroDB. That could have, just for example, you click on a point on a map and it gives you a little bit of information and then a link back to HydroClient for fuller exploration. So the main point is that there are web services and you can leverage them to build lightweight applications. You don't have to be dependent on all your data is now at CUAHSI and you have to point everyone to CUAHSI alone to give them any picture of your data.
So what I really appreciate now is that this gives me all the precipitation data that are around our site. So I can put them all together, or all temperature data that are available. And so these are obviously very different ones. This is ours. And then if I go here, this is NOAA.
If you go to the filter results, you can see them all.
This one?
So a little further down. you see them
there
all
they are.
there.
Yeah.
So these are all the ones that are there. You can subset your result set with different additional attributes, and then combine them in one download. So you can combine, essentially you pick 4 or 5 and then select them, and they are combined and concatenated in one large CSV file. You sort of that.
Oh, see here I'm already seeing some discrepancies of how people have used the controlled vocabulary.
Yeah.
So you can see that the sample medium is precipitation, or I called it air. So any recommendations? And then obviously there's climate and hydrology in the general category. So we may want to agree on a few things on how we label it.
Yeah.
What about the icon? NASA has an icon.
Yeah, you can have one too.
Huh?
You can have one too.
It looks like a
Yeah, when you register the
icon.
when you register the service, you can upload an icon, and that is harvested as well. So that you can see that in here as well if you have an LTR icon you want to see. So hey, we got it all.
All right, I think our time is up. Thank you, everyone. Thanks for coming, hanging in here.